Hi, good day, and welcome to the Division of Education, Innovation and Energy e-learning program. I'm one of your maths facilitators, Frederick, and for this video, we shall be continuing our exploration of algebra. Let's look at another example. Look at this one here. Woo, this one is nice. Let's see. It is 5 upon 3x plus 3 upon 2x. Again, what are the steps or what are the questions that we need to ask ourselves as we attempt to solve or simplify algebraic expression or algebraic fractions utilizing addition? The steps are, the questions are, what are the questions here? Questions are what? Come questions, let's see you. Oh, here are the questions. Questions. What is the lowest common denominator or lowest common multiple of our denominators? In this case, we have, in the denominators, we have algebraic expressions. It is 3x and 2x. So, what are we going to do? Remember the steps from last time. Take your denominators. What's the problem again? The problem is 5 upon 3x plus 3 upon 2x. Then take your common denominators. What are your common denominators here? It is 3x and 2x. So we ask ourselves the question again. Hold for me. When we did multiplication, and you need to check that video. When we did multiplication and division of algebraic expression or algebraic terms, we did state that you see 3x? 3x is actually 3 multiplied by x. And you see 2x? 2x is actually 2 multiplied by x. So if we are looking for common factors or if we are looking for some number, some entity that we can divide 3x by or 2x or both, we can say that here's what, starting with what we know, numerically first, the numbers first, starting with what we know, we are going to utilize 2. 2, can 2 go into 3x? Of course not. So what are we going to do? We are going to write back the 3x. Can 2 go into 2x? Of course it can. The 2's can cancel. So it's going to be 3x and the 2's have cancelled out. I am left with x. Then we say, looking now at these here, it's 3x and x. What can divide either 3x or x or both? And yeah, that's going to be 3. So we put our 3, and 3 into 3x is going to be, of course, x, and 3 into x cannot, so we write back our x. Now we have x, x. What can divide x? X or both. It's going to be x, right? So it is x. X into x is 1. X into x is 1. We now can make that prediction. Prediction. What is our prediction? Our lowest common denominator is going to be all of these here multiplied. All of these here multiplied, the product of these would give us our lowest common denominator. Our lowest common denominator here is going to be Bazinga. That's right. It's going to be 6x. So, now that we have our lowest common denominator, the next question that we need to ask ourselves is this. What's the next question again? Can you recall? The next question is, correct is right. How many times must each denominator be multiplied to give the lowest common multiple? What is my first denominator here? My first denominator here is 3x. And here's what. We did a video for you on the multiplication of algebraic terms. So if you have forgotten or if you don't fully understand what I'm doing here, just check back on that video before you proceed. I'll wait for you. Right, so you're ready for me. So it's 3x is my denominator here. 3x is my denominator, and I'm asking myself, what need I multiply this 3x by to get my lowest common multiple or lowest common denominator, which is 6x. 3x multiplied by what is going to give me 6x? Let's see. Correct is right. 3x multiplied by 2. What we then do is that we take that 2 and multiply that 2 by the numerator. So that gives me 2 times 5. And then I ask myself now, what is my next denominator? My next denominator is 2x. 2x multiplied by what is going to give me my common denominator? That is going to be, let's see, that is going to be 3. So 2x by 3 is going to give me 6x. I then take this 3 and multiply it by my numerator. So it's going to become 3 times 3. What I then do is I simplify my numerator utilizing BODMAS. I have multiple operations. So I'm going to do multiplication first. So it's going to give me here now 10. 2 times 5 is 10. And then 3 times 3 is 9. And all upon my common denominator is going to be 6x. I can work out 10 plus 9. What is 10 plus 9? 10 plus 9 is 19. So it's 19 all upon 6x. And I've simplified this algebraic simplify this algebraic system utilizing addition. Let's look at another example. Looking at another example here, we want to simplify 5x minus 2 all upon 6x plus 3x plus 1 all upon 4x. This one looks nice. I like this one. Initially looking at it, it appears a little challenging, does it not? But I can assure you that once you follow those steps, or once you ask yourself those pertinent questions, you can simplify this. Let's see. Oh, just now, hold a minute. Look at that problem for me. I'm sweating slightly. So I'm going to take 1, 2 dabs. The maths thing making me sweat a little bit, you know. Maths thing nice. The maths thing nice? The maths thing nice. Right, let me go. Dab in a little bit. Dab, 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 dab. Right, I'm ready for the maths thing now. So, what are the questions that we need to ask ourselves? The questions that we must ask ourselves are what? Can you recall those questions? The first question is, what is the lowest common denominator? In this case, we take our denominators. The computer moving ahead of me. Take our denominators, it is 6x and 4x. So we write 6x and 4x. And then we ask ourselves, what can divide either 6x or 4x or both? What do we have? We have 2. So 2 into 6x is going to give me what? 2 into 6x is going to be 3x. And 2 into 4x is going to be 2x. And then we evaluate these here now. Evaluating these, we ask ourselves, what can divide either 3x or 2x or both? It's going to be 2. So 2 into 3x. Can 2 go into 3x? We saw from before that it can't, so we write back the 3x. Can 2 go into 2x? Of course it can. 2's can cancel. So this gives us here now 3x and x. What can go into either 3x or x or both? We are saying that that is going to be 3. 3 into 3x is going to give me x. And 3 into x, is x. And so it's x and x we have here. So what can go into x and x? It is going to be x. And I would come and have here now. What would I have here? X into x is 1. X into x is 1. Once I have 1's in the bottom here, we are ready to make a prediction. What is our lowest common denominator? Our lowest common denominator is all of these here being multiplied. It is x by 3 by 2 by 2. And that is going to give us what? That is going to give us 12x. Question number 2 that you must ask yourself when working algebraic fractions or simplifying algebraic fractions. The second question that you must ask yourself is how many times must each denominator be multiplied to give the common denominator or LCM? So here, my denominator here is 6x. I'm going to ask myself, how many times must 6x be multiplied to give me 12x? 6x multiplied by what? 4? No, that is not correct. 6x multiplied by 4, 6 times 4 is not going to give me 12. So that is wrong. It is actually 6 multiplied by 2. Right. So 6x multiplied by 2 is going to give me 12x. So we take that 2 and we multiply the 2 by the entire numerator. Multiplying that 2 by the entire numerator, it becomes 2 multiplied by the entire numerator. It's 5x minus 2. Now bear this in mind, that in mathematics from time to time, like I guess I did, you are going to make some mistakes. So it's very important that you check over your work to ensure that the answer that you want to have is the answer that you are supposed to have. For those of you preparing to go into exams, please utilize that rule of thumb. After you have completed a solution, check over that solution set to ensure that all the steps that you have and all the calculations that you have conducted, those calculations are the ones that you want based on the system that you have utilized, BODMAS, etc. So please don't make a similar mistake to the one that I've made. Yes, now I know that in mathematics we make mistakes from time to time, but it's important that we try our best to eliminate or diminish the amount of mistakes that we can make. So it is 2. 6x multiplied by 2 is going to give me 12x. We take that 2 and we multiply the 2 by the entire numerator. We come across here and we do the same thing across here. 4x multiplied by what is going to give us 12x? 4x multiplied by, let's see, it's going to be 4x multiplied by Bazinga. 4x multiplied by 3. This one is correct. 4x multiplied by 3 is 12x. So we take that 3 and we multiply that 3 by the entire numerator. Now we need to do some simplification here. I pause to remind you that we did a video on the distributive property of multiplication over addition and subtraction. Here, to further simplify this, we need to utilize that because we are arguing that this 2 has to be multiplied by the 5x and this 2 has to be multiplied by the negative 2. So also this 3 has to be multiplied by the 3x and this 3 has to be multiplied by the 1. So utilizing the distributive property to simplify, it is 2 times 5x is going to give me 10x and 2 times negative 2 is going to give me what? Is going to give me negative 4. We do the same thing here. It is 3 times 3x is 9x and 3 times 3 is 1. So it's going to be positive 3 by 3x. Signs are important, eh? Signs are important. Positive 3 by 3x is going to give me 9x and positive 3 by 1 is going to give me 3x. So we end up with here what we end up with. 10x minus 4, 10x minus 4 plus 9x plus 3 all upon 12x. Now, what we need to do here is we need to, listen, we don't do mathematics in silos. By that we mean that we don't compartmentalize mathematics. The rules are general rules that are applied throughout as you navigate mathematics. So yes, we are working algebraic fractions, but we did do addition and subtraction of algebraic terms. So you need to ensure that when you have terms in algebra and you recognize that addition and subtraction is taking place, that you refer back to the rules that you would have utilized for the addition and subtraction of algebraic terms. So here in my numerator, we have some addition and subtraction taking place here. Can this numerator be further simplified? And if you have forgotten, or if you can't recall how to do addition and subtraction of algebraic terms, please check one of our previous videos on our website. So here, we are doing addition and subtraction of algebraic terms, group-like terms together. We have 10x plus 9x minus 4 plus 3. Utilizing those rules that you just checked on addition and subtraction of algebraic terms, it gives us what here now? Well, my common denominator. It gives us 19x minus 1 all upon 12x. And this here cannot further be simplified, so that is our final answer. And we have simplified utilizing the addition and subtraction of my algebraic fractions. Let's look at another example. Look at this example here. Simplify, what are we simplifying here now? It is 2 upon m squared n plus x upon m n squared. How do we simplify it? We have to ask ourselves the same questions. What are the questions we have to ask ourselves? Questions we have to ask ourselves are question 1. What is the lowest common denominator or lowest common multiple? You remember how to do that? Write down our denominators. What are our denominators here? Our denominators here are m squared n and mn squared. Take those denominators. Remember from our video on multiplication and division of our algebraic terms, what this here represents. Mn squared is m squared multiplied by n, and mn squared is m multiplied by m squared. So we are going to look at what a variable or what number can we use to divide either m squared n or mn squared. We are going to start with here what the m. It's taking the m into m squared n is going to give us what? Of course, it's going to give us mn, and m into mn squared is going to give us n squared. We then ask ourselves, what can we divide either mn or n squared by, or both? And in this case, we're going to try the m again. Taking out the m, it's going to be m into mn is n, and m into n squared is going to give us n squared. Now we are left with only n's, so it's expected that n is going to be one of the things we are going to use. N into n is what? N into n squared is what? N into n is 1, and n into n squared is n. Going down the road again, trying n again. We have n into 1, cannot, so we write 1, and n into n is 1, so it's going to be 1, 1. Now that we have that, our lowest common denominator, again, is going to be all of these here multiplied. So, lowest common denominator, all of those being multiplied, and that the product of those gives us our lowest common denominator. So, my lowest common denominator here is going to be m squared n squared. So, we go on now to our next question. After we have the lowest common denominator, our next question is what? Our next question is, how many times must each of the denominators that we had initially be multiplied to give the lowest common denominator? So how many times do I, or what need I multiply m squared n by to give me m squared n squared? Again, please refer to that video that we did on the multiplication and division of algebraic terms. So what need I multiply m squared n by to give me m squared n squared? And that is going to be, of course, n. And we take this n now and we multiply this n by the numerator. So it's going to be n times 2. Yes. And we tried for this one as well, this denominator. What need we multiply mn squared by to give us m squared n squared? And that is going to give us what? It is going to give us, that's right, by m. So it is going to be, take this here now and multiply by our numerator. So it's going to be m by x, which is going to give us what? Simplified? Let's simplify it. So it's going to be n times 2 is going to give me 2n, and m times x is mx. So I have 2n plus mx all upon my common denominator, which is m squared n squared. This here, utilizing addition and subtraction or multiplication and division of algebraic terms, this here cannot be further simplified. So that is our final answer, and we are done. Looking at another example, let's look at another example. Looking at another example, and now starters break out to that nice sweat, lady sweat. Yes, maths is a nice sweat. And looking at another example, addition and subtraction of algebraic fractions. Hold on, we're not looking at any more examples. Let's see what we have here. This is another example. We are able to make a prediction. What is this prediction? The prediction is this. The prediction here is this. What is the prediction we are able to make? For each variable, the contributor to the lowest common denominator is always the one with the largest exponent. Oh, interesting concept. Let's try it again. So the prediction that we want to make here is that for each variable, the contributor to the lowest common denominator is always the one with the largest exponent. Let's see an example of that. An example of that is going to be what? Simplify. Let's simplify. What are we simplifying? We are simplifying 4 upon a squared b plus a cubed, plus 2 upon a cubed b. So, again, first step is to determine our lowest common denominator. What is our lowest common denominator here? We are saying that we don't have to go and do all the long division. What we need to bear in mind is that prediction, that the contributor to the lowest common denominator for each variable is always the one with the largest exponent. So here, for my variable a, the exponent here is 2, the exponent here is 3. So therefore, the contributor to the lowest common denominator is going to be the one with the largest exponent. That is going to be a cubed. And here I have b squared, and I have b. My contributor is going to be the one with the largest exponent. This b here has an exponent or power of 1. This has a power of 2. So largest exponent here is a cubed. Largest exponent here is b squared. My lowest common denominator here is going to be, correct is right, a cubed b squared. Now that we have our lowest common denominator, we continue as we were doing from before. What need I multiply a squared b squared by to give me a cubed b squared? And we are saying Bazinga, that is going to be multiplied by a. So now we have a multiplied by the numerator. We take this a and multiply it by the numerator. So it's a multiplied by 4. And then we ask ourselves for this one as well. What need we multiply a cubed b by to give me a cubed b squared? That is going to be Bazinga by b. So we take this b and we multiply it by our numerator. So it's going to be b multiplied by 2. And now we do some simplification. What is a times 4? A times 4 is 4a. And what is b times 2? b times 2 is 2b. So we end up with here 4a plus 2b all upon a cubed b squared. Now again, using our laws of addition and subtraction, multiplication, division of algebraic terms, this here cannot further be simplified. So that is our final answer. Let's look at another example. Here, it is simplify. What we want to simplify? We want to simplify here 2 upon p squared q plus 1 upon p squared q squared minus 5 upon p q cubed. Our prediction was what? Our prediction was that the lowest common denominator, the contributor for each variable to our lowest common denominator for each variable is always the one with the largest exponent or largest power. So if I'm looking at my p's here, it's p squared, p, the largest or the biggest power is 2. So then my contributor for my p's to my lowest common denominator is going to be p squared. And for my q's, I have q here, q squared, q cubed. The contributor is going to be the one with the biggest power or largest power. So it's going to be p squared and q cubed. So let's see. Lowest common denominator, that's our problem again. Lowest common denominator is, where are you? Here it comes. It's p squared and q cubed. So now that we have our lowest common denominator, the next question that we ask ourselves is this. What can each of these denominators be multiplied by to give us our lowest common denominator? So my first denominator is p squared q. What must I multiply p squared q by to give me p squared q cubed? It's going to be, correct is right, it's going to be q squared. So p squared q multiplied by q squared is going to give me p squared q cubed. So we now take this q squared and multiply it by our numerator. So it becomes here, what does it become? It becomes q squared multiplied by 2. We do it for this one. This denominator here is p squared q squared. What must we multiply p squared q squared by to give us p squared q cubed? And you have it right. It is going to be multiplied by q. P squared q squared multiplied by q is going to give me p squared q cubed. Now, remember, if you have forgotten how to multiply your algebraic terms, check a previous video. We have done all the videos for you. So it's going to be multiplied by q. We then take this q here now and multiply it by our numerator. My numerator here is 1. So it's going to be plus q multiplied by 1. And finally, it's negative. Negative, so I'm going to have to put my negative sign here. And it's p q cubed multiplied by what is going to give me p squared q cubed. What do we need to multiply that by? Correct is right. It's going to be multiplied by p. So p q cubed multiplied by p is going to give me p squared q cubed. We then take this p and multiply it by our numerator. So it's going to be p multiplied by 5, remember the negative sign, and now we simplify. So multiplying out here, we have this is going to be 2q squared multiplied by 2, and q multiplied by 1 is plus q, and negative p multiplied by 5 is negative 5p. Now here, we can't further simplify my numerator, so my final answer here is 2q squared plus q minus 5p all upon p squared q cubed, and that's our final answer. Let's look at another example. Let's see what we have here. Look at this one. Simplify. What are we simplifying here now? We are simplifying 5 upon a. This one is a little bit more, what should I say? I don't want to use the word challenging, although it's good to, face a challenge. But it's a little different from what we have done before. It is 5 upon a plus 2 upon a minus 3. Again, it's algebraic fractions. We want to add our algebraic fractions. So what we must do is that we must go back to questions we need to ask ourselves. And the question is, what is my lowest common denominator? To get my lowest common denominator, I take my denominators. What are my denominators? A and a minus 3. Now here's what. We are going to then utilize division. But I can't divide out. I've seen persons do this. A minus 3 all upon a, and they cancel out the a's. If you check back on our video of multiplying and dividing algebraic terms or algebraic expression, you would know that we cannot divide across an addition or subtraction sign. So this here, it would be treated as if it's one term. This expression would be treated for our division purposes as if it's one term. So the only thing that can divide this is a minus 3. So again, what we do here, we say, what can divide a or a minus 3 or both? Here in this case, we are going to try the a. A into a is going to give us 1, but a into a minus 3, remember, we cannot divide across an addition or subtraction sign. So a into a minus 3 cannot. We need to write back the a minus 3. And then what we try, because we are treating this here as if it's one term, it cannot be factorized in any way. So we try the a minus 3. So a minus 3 into 1 cannot. We write 1. And a minus 3 into a minus 3 is going to give me 1 as well. I have 1, 1 below here in my bottom. So at the end of my problem, I should say, so my common denominator is going to be, take these here and multiply them. So it's going to be a and a minus 3 being multiplied. The product is going to give me my lowest common denominator. And so my lowest common denominator here is going to be a multiplied by a minus 3. I then ask myself, what need I multiply this a by to get a multiplied by a minus 3? And that is going to be a minus 3. So I take that a minus 3 and multiply by the numerator. It gives me a minus 3 multiplied by numerator. And then the same thing across here. What need I multiply a minus 3 by to give me a into a minus 3? And that is going to be a. So I take that a and I multiply the a by the numerator. So I now have a minus 3 multiplied by 5 and a multiplied by 2. Distributive property comes into play. Check that video on the distributive property and distributive law of multiplication over addition and subtraction. So I need here now to multiply the a by the 5 and the negative 3 by the 5. A times 5 is 5a, and a times 3, or sorry, not a times 3, but negative 3 by 5 is negative 15. And a times 2 is going to give me 2a. All upon my common denominator is a, all into a minus 3. Again, laws of addition and subtraction of algebraic terms, Laws of addition and subtraction of algebraic terms, group-like terms together. So it's going to be 5a plus 2a minus 15, all upon a into a minus 3, which gives me 7a minus 15, all upon a minus 3. And that is my answer. It cannot be further simplified. Let's look at another example. For this example here, what are we going to do? We want to simplify 5 upon m minus 2 plus 3 upon m plus 2. Here's what. I'm going to leave this one with you. I want you to attempt this one try this one, sorry. I want you to attempt this one. I want you to try this one. When we come back in the next video, I shall be working this one for you. So let me see what you come up with. For this one, it's 5 upon m minus 2 plus 3 upon m plus 2. Try this one, and I will see you back in the next video when we shall be doing multiplication and division of algebraic fractions. Thank you for being a part of this exciting video as we explore algebra and, more importantly, algebraic fractions. See you until next time.